Hello, dear students. Welcome back to the session on problems on single block break or single shoe break. So, in the previous discussion, we have come across for the given block or the shoe, uh, we have calculated the operating force or the actuating force required uh, to apply the brake for clockwise rotation and anti-clockwise rotation of the drum. Along with that, we have calculated normal force, tangential force, all those are the steps included in respect to that particular problem. Now, let us consider the second problem. So, in this, the power that is to be transmitted through power that is to be absorbed during the application of brake, that we have to determine here. So the operating force that is what called as the braking force, which is given as 900 newtons here, and COF coefficient of friction for this arrangement, that is a coefficient of friction between the drum and the shoe, is given as 0.25. The drum rotates at 600 rpm. So these are the informations which are given. In addition to that, the block diagram or the diagram of the single block brake is given. So with this given sketch, we have to note down some of the other informations also. So here the value of F that is given, and see here in the previous problem, the block or the shoe that is placed below the drum. But here in this problem, the block or the shoe is placed up at the upside or upper side of the drum or the rotating wheel, so that the equations are different here. So as we know that in the previous discussion, there was a note that was written that if it is the situation, we have to use clockwise formula used in the or given in the data handbook for anti-clockwise rotation, and anti-clockwise rotation formula given in the data handbook for the clockwise rotation of this particular sketch. So as the drum is rotating in clockwise direction, and F is operating force, which is given here, and the distance between the fulcrum point and the center of drum, that is denoted by means of the notation B, which is given as 210 mm, and the distance between center of the drum and the actuating force is given as A, that is equal to 300 mm, given it is, and the diameter of the drum, that is also given here as 300 mm, so that the value of radius of the drum is 150 mm. So in addition to these things, we have to indicate or we have to get the value of C, which is not given here. So since C is not given, but instead of C value, what is given, say the distance between the fulcrum point and the center of drum, that is 90 mm is given, but this is not C. So C is what? That is the distance between the line of action of FT and the center of fulcrum. So this value is C. So this value is C, means here 90 mm is the distance between center as well as fulcrum point is given. And also we know that the radius of the drum R, that is the 150 mm value. So to get C, I have to subtract 90 mm from this R, so that the value of R minus 90 is written here. That is 150 minus 90, that is equal to 60 mm. Therefore C is equal to 60 mm. So this is the third parameter that is required while calculating the required thing. Then it is rotating in clockwise direction, which is given, so that we have to make use of counterclockwise rotation of this arrangement as per the data handbook. But what is the case that we have to consider here? See the line of action of FT that lies above the what, above the center of drum and above the center of drum and the fulcrum point, right? So what we can say here, say the line of action of FT that is above the fulcrum point as well as center of drum. So this becomes we have to refer for this kind of situation figure C of the data handbook, page number 267, page number 267 of the data handbook. So with respect to this page, and by referring figure C, so since the block is placed upside, so and the drum is rotating in clockwise direction, so we have to make use of counterclockwise rotation formula, that is 13.17 E, 13.17 E equation that we have to make use to calculate the value of f or unknown parameter. So this is the thing. So with this information, so you have to proceed with the calculation part. So now here the block or the shoe is placed upside and the drum is rotating in clockwise direction, and the ft acts away from the pivot. As it is rotating in clockwise direction means in the same direction the value of ft, or the action line of action of ft, that is there, that is away from the fulcrum point, away from the fulcrum point, and lies above the center of drum and fulcrum point, above the center and fulcrum point. So we have to refer the figure C of the data handbook, page number 267, and we have to use counterclockwise formula by using equation number 13.7 e. 13.7 e it is, that is not C, that is e. So we have to use that equation. So for this purpose, we have to consider the equation, or I have to make the changes, some changes here. Say this is e, this is not C, this is e of data and equation, and here also the same thing, we have to write it as e. Page number 267. Next, we have to use that equation, or we can use the moment equation also. But fundamentals say taking moment about point C, point O, that is fulcrum point, F into A plus B, F into A plus B. If I take the moment F into bracket A plus B into, that is F into A plus B plus Ft, that also gives the moment in the same direction. So it is added with this Ft into the perpendicular distance is C, and then the minus, so this gives the moment in opposite direction. So Fn into B minus with a negative sign, and this summation is equated to 0, and this is based upon the equilibrium condition where summation of moment is taken about the fulcrum point and equated to 0. So these are the different moments that we can come across here about the fulcrum point. So that if I simplify or if I solve this equation, and I will be getting the standard equation, that is f of a plus f is equal to fn into b minus ft into c divided by a plus b. Suppose if I substitute fn, or fn is replaced by ft by mu ratio, then the equation is like this. So this equation is as good as equation number 13.17e for the third case, figure C of the given situation. So here you know the value of f, and ft is unknown. That's what we have to find out here. Ft is the parameter that we have to determine. So this is the thing that is required here. And with respect to the other information, say b is given, and a plus b, these two values are also given, and then mu is also given, that is 0.25. Since 2 theta is less than 60 degree, as the value is not specified, it means that this value is 260 degree itself, that is angle of lap, and C is 60 mm and B is 210 mm. So that the value of Ft that is obtained here, that is 588.5 newtons. And then in the next step, we have to go for the calculation of torque. Torque is given by Ft into R, fundamental expression. Say in the previous case, from this torque we have calculated Ft, but here Ft is to be calculated from the given value of F, and then torque T is to be calculated with the known value of Ft. So that value is 88,269.2 Newton mm, and then it is to be converted into meters. So that 88.269 Newton meter. So this is what the torque calculation. So the next step itself is to calculate the power. So power from fundamental expression, that is 2 pi nt divided by 60 into 1000. So this value is, or this equation, we know the different parameters, such as n is 600 rpm given, torque is 88.2692 Newton meter, and divided by 60 into 1000 conversion factor. So that the answer what we get is 5.6 kilowatts. So this is what the required answer as per the question statement. So here the block is placed upside, and that is what the difference here. So if we take the next problem, say problem number 3, In this problem, single block break with a drum diameter of 350 mm. 350 mm. Say that is what the diameter of the drum, and is shown in figure. The angle of contact. See here, the angle of contact that is represented by means of the notation 2 times theta. So that value is 90 degree here. That is more than 60 degree. So the coefficient of friction is given as 0.33. Determine the safe power that can be absorbed by the arrangement, and it is rotating with the rpm of 1440 rpm, 1440 rpm. So that with respect to the given sketch, see here again the block is placed at the upside, and the line of action of ft, line of action of ft that lies above the center of drum as well as fulcrum point. So above these two values, above the center as well as fulcrum point, the line of action of ft that lies. So this refers to the figure c of the data handbook, figure c of the data handbook, which is available in page number 60. So figure C, but the arrangement is reversed. So the block is upside here. So that we have to reverse the cases. So clockwise formula for counterclockwise rotation and counterclockwise formula for clockwise rotation. So here we have to make use of counterclockwise rotation formula. So this is what the thing. And in addition to that, there is something that is given. That is what the value of 2 theta, which is equal to 90 degrees. Since it is greater than 60 degrees, greater than 60 degrees, then we have to calculate the equivalent coefficient of friction mu dash. Equivalent coefficient of friction mu dash. So mu dash is given by 4 mu into sine theta divided by 2 times theta into sine of 2 theta. So this is available in page number 266 of the data handbook, just below the equation 13.16 m. 13.16 m. So by using that equation, mu dash is to be calculated. So mu dash is what? Mu dash is equivalent coefficient of friction, because this value is to be used in rest of the equations in place of mu. Wherever you have got the equation of or the term mu, that term is to be replaced by the equivalent coefficient of friction, since the value of 2 theta is greater than 60. Greater than 60, that is 90 degrees. Therefore, mu dash is essential here. So the equation is 4 times mu. Mu is given 0.33, and 2 theta, that is pi by 2, that is in radians. 90 is converted in terms of radians. So that is what? 2 theta, that is pi by 2, and sine of 2 theta, that is sine of 90 degrees, no doubt. So equivalent coefficient of friction is calculated here as 0.363 after substituting all the values. So this is the calculation of mu dash. So the next thing is to get the value of or see the particular arrangement of the sketch. So above figure, in above figure, the line of action of ft is away from the fulcrum, as the drum is rotating clockwise here, so that in the same direction of rotation ft that acts, that is away from the fulcrum point. And then the lies, it lies above the center and fulcrum point. So it may lie above or below the center of center and fulcrum point. So the figure c refers to, in the figure c available in the data handbook, page number 267. There the block is placed, or the line of action of ft, that is below the center of drum as well as the fulcrum point, but here it is above because of reversed case. So figure C is to be referred here from data handbook, page number 267, and you have to use the counterclockwise formula, that is 13.7 E. 13.7 E of the data handbook. So by referring equation 13.7 E of page number 267, we have to use the equation of F to calculate the actuating force. So in this mu, the term which is present in the equation 13.17 E, that is mu here. So that mu is to be replaced by mu dash, because the value of 2 theta is more than 60 degrees. Therefore, it is to be substituted here as equivalent coefficient of friction, what we have calculated here. So that is 0.363. And remaining terms that are known, so whichever the terms they are known, they are to be substituted here. See, F is known, that is substituted here 500, and B value is known, A plus B is also known, mu dash is also known, C by B, C value as well as B value, they are known, so that the value of 50 tangential force is calculated. So by using the fundamental equation of torque T, Ft into R is equal to torque. So substitute and get the value of torque in Newton mm and then Newton meter. After that, calculate the safe power absorbed during the application of brake, that is 2 pi nt divided by 60 into 1000 equation that we have to use. So n is 1440 rpm is given, 1440 rpm is given, 78.88 that is Newton meter torque. So divided by 60 into 1000, so the answer is 11.89 kilowatt. So this is what the another kind of problem where the equivalent coefficient of friction is to be calculated for the value of 2 theta is greater than 60 degrees. Suppose if it is less than 60 degree or up to 60 degree, the mu is directly that we have to substitute in the equation. So in the next session, I will take one more problem on the single block brake where the design of this block as well as lever are to be carried out. Thank you.